So today we're going to be looking at chapter 12, which the name of the entire chapter is conics. And if we take a look at day one, this is we're going to get the introduction here, where conics are the curves formed when planes intersect the surface of a right circular cone. Now, what does that look like visually? Well, if you take a look over to the right-hand side, if you have two cones facing each other and you were to make particular slices at a certain angle, you will get different types of conic sections. And the first one that we look at is one that we've talked about in multiple classes, is just the circle. So if I take that slice horizontally across there, I just get a nice looking circle. Hopefully it just looks a little better than mine. The second one in this chapter that we're going to focus on is the parabola. Now you look at the parabola, yes, you've seen it in different algebra classes, but what it comes from is if you take a slice at a certain angle right there, is that you will get a parabola, and usually we look at parabolas that go up and down, but we're also going to, later on this chapter, look at parabolas that go to the right and to the left, okay? Now the next slice that we're going to look at, next conic section we're going to look at is something called the ellipse, which is similar to the circle. If you take the slice right there, all right, it looks like ellipse, as my children at home call it, just an oval, and it could be a horizontal ellipse or a vertical ellipse, okay? And then we're going to finish out the chapter looking at something called the hyperbola, which basically, yes, as you look at that and you see if you make a vertical slice this way, you get two parabolas going away from each other, so you could have either both of them be vertical, or you could have both of them be horizontal. Now, as I said, these three we're going to look as the chapter goes on later on. But for today, we're going to focus on circles and then just getting some basics to make sure you have some basic skills that you've learned from previous classes. So if we look, here's some old formulas. If you want to pause right here to see how you do and test yourself, you can do that. Otherwise, let's go through them and see what we got here. So if I take the distance formula between 2 points, we know that that's just going to be the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, right? So that should look familiar. A lot of these should look familiar as we're going through. A couple of them will be new, so make sure you pay attention on those. Circle equation, right? If we have just x minus h squared plus y minus k squared equals r squared, this is when your center is located at h comma k, and then your radius obviously is just r. Okay. Another formula we got here is slope of a line, right? We just use the letter m is equal to the difference between the y's over the difference between the x's, right? You got delta y, delta x, rise over run, however you want to phrase it. You've been doing that for many math classes. Slope-intercept form, well, that's just when you write equation of a line, y equals mx plus b. Point slope, this is one, especially for you guys that take calculus next year, you will use this often. So make sure you memorize it if you haven't done so already. It is y minus y1 equals m parentheses x minus x1. And you're going to be replacing the values that get replaced in this is y1, m, and x1. So hopefully you've done that last year. If not, we will get to that in a little bit to show you how to use that, because that is, again, an important formula that you will use in calculus next year besides this year. Midpoint formula, right? We just know that I'm going to abbreviate here. The midpoint is basically just the averages of your x's. So if you take your x1, add it to x2 divided by 2, comma, y1 plus y2 divided by 2, right? It's an ordered pair, so that's why you have the comma there and not just an equal sign or just one number. You got two numbers. Now you should remember parallel lines, everyone's favorite class, geometry. Parallel lines are just lines that have the same slope. And we know that perpendicular lines are when you take a look at lines that have opposite, I'm going to abbreviate here, reciprocal slopes. Hopefully those, you remember those particular from last year or the year before. Okay, so there's just some basic old things that you should hopefully remember. If you haven't, you have it right there for you to go back and look at when you're doing the homework for today. Let's actually look at a couple more things. We got some new things here. Get to the top of the page. Okay, some new formulas. Angle of inclination. Now what that is that is the angle. Typically, we call that theta. That's what the Greek symbol for theta is, if you haven't seen that before. The angle, theta, that is measured clockwise from the positive x-axis to the line we're referring to, okay? And the angle of inclination will always be between 0 degrees and 180 degrees, or 0 radians and pi radians. Now this 0 radians and pi radians, if you've seen that last year, okay, we haven't done that much this year, if at all, so we'll get into that more. This is more of a second semester topic, but if you've seen that, great. If not, don't worry as much about that, but the biggest thing is realize it's going to be between 0 and 180 degrees, okay? So if you take a look at just a couple of examples, right, if I draw a line on a grid, and it goes up in that direction, right? There's the positive x-axis. So I would say that my theta, or my angle of inclination, would be finding how many degrees or how many radians is from the x-axis to that line, all right? So if I look at a different example, let's say I were to tell you that the slope of a line is 2. Oh, gotta go back. I forgot to add something right here. We have a formula that we need for this. Sorry about that. M equals the tangent of theta. That's just the formula that we're going to use to help us find that angle of inclination. Sorry about that. Make sure you go back and add that into your notes. All right, so if I get a slope of 2, so basically if you think about a slope of 2, well, if we were to draw a line here, right, that would have a slope of 2 because you go 1 horizontally, you go 2 up, right? We've done slope multiple times in your life. So we know that the slope is 2 there. Well, what we can do is use this formula to find the angle of that inclination. And we just know the formulas I just set up there is tangent of theta is equal to m. So in this case, tangent of theta is equal to 2 in this particular example. And what I can do if I want to solve for theta, remember back when you did a little bit of trig in your previous classes, is that if we were to take the inverse tangent of both sides, so we would say that theta is equal to tangent -1 of 2. Remember, that's called the inverse tangent or arctangent, which we'll focus on that a lot more second semester, but hopefully you do remember that from previous classes. This is just calculator question. Just go ahead and type in your calculator. If you are in degrees, so this is a great chance for you to check and see that you're doing this correctly. If you are in degrees, then you should get roughly 63.43 degrees. Okay, so this is all you have to do in your calculator. This is where you put second tangent. The tangent -1 pops up. You type in the number 2, hit enter, and you should get roughly 63.43 degrees. That's if you're degrees. Some of your homework will also ask you to give the radian answer. And if you do in radians, you should get 1.11. So I do the same thing on your calculator. Second tangent, or tangent -1 of 2. Make sure your mode is put in radians, and you should get roughly 1.11 radians. So this is a good chance for you to check that you're using your calculator correctly, okay? So that makes you go back, try that, and see if you're doing that right. All right, to give you another example, a little bit trickier one. If I were to say the slope of a line is -4/3, so typically you'd say, well, if I do -4/3, if I'm starting at the origin, I would be going down into the 4th quadrant, where you would go down 4 and you would go 3 to the right. And you would say, okay, I'd go, my line would look going in that direction. All right, so we can use that same formula. Say the tangent of theta is equal to -4/3. Again, using your calculator, arctangent, second tangent, -4/3. If I just do the degrees in this instance, If you do it correctly, you should get a negative 53.13 degrees, because all that means is that we're going down in this direction roughly 53.13 degrees, right? That would be the angle here. But remember, from the directions, it says that our angle has to be between 0 and 180. So what I have to do for that is, instead of going down to the right like you would with the negative angle typically, is if I go the exact opposite direction, I have to find out this angle instead. This is what I need, is I really want to find that angle, because that will be between 0 and 180 degrees. Well, how to do that is, we know that if this angle right here is 53.13, that means by vertical angles, oh, some good geometry review right here, this is also 53.13 degrees. Okay, so if I want to get the blue angle, right, that's my answer that I want, between 0 and 180. If this is 53.13, you guessed it, I got to do some subtraction. So I would have to go through and say, well, the whole thing, a straight line is always 180 degrees, but I want to subtract that 53.13 because I'm that much short of a full straight line. So in doing that, I get roughly 126.87 degrees. And that would be the angle of inclination. And something like that, an obtuse angle, will always happen when you have a slope that is negative, because you'll end up in the second quadrant if you do that right. So over here we had positive slope, we had first quadrant, we got a nice acute angle. Here we had a negative slope, so we end up in the second quadrant, so we have an obtuse angle. Okay, so make sure that you see the difference between those. So when you see that in a quiz or test, you are all good to go for those types of problems. Okay, all right. Some more new information, I'm assuming. Distance from a point to a line. So basically, if we look at this as a diagram, we have some type of line over here. If I want to find the distance from this point to that line, right? So if I want to find the distance, you would do the perpendicular distance. That's kind of what you're looking at to find that. So the blue right there would be the distance that we're talking about. And it's just a formula that you're going to have to make sure that you memorize. And what it comes out to be is that D is equal to the absolute value of M times x1 plus B minus y1, that's all absolute value, all over the square root of 1 plus m squared. Okay, so let's break that down here. So if my equation is in slope-intercept form, I'm just going to use that distance formula. So make sure you highlight that, asterisk it, whatever you want to do, because we're going to come back to it. We're going to need that one. So this is how we use it. Find the distance between the point -2 and -2, -3, and that line. So obviously this is going to be x1, and this is our y1, and then y equals -4x plus 1. Well, we talked earlier, this is just your m, and that's your b. So if you've memorized your formula, all we're going to do is, you want to find the distance, we're just going to use this equation. So d equals the absolute value. We'll go back over here. We see that the slope is -4. x1, that's just the x coordinate of the point that we're talking about. So in this case, we're talking about -2 being the x coordinate of that point, plus the b value. Well, the b is a nice little 1, right? That's right there. Minus, well, that's the y coordinate of that point. So minus a -3 absolute value all over the square root of 1 plus, well, we already said our slope was -4 squared. So once you have your formula, now it's a matter of just plugging in the numbers correctly, making sure you know which is your m, which is your b. That should be easy. And then getting your x1 and your y1 from the point that's given. So all I'm going to do is just simplify this. I'm going to see if I clean up the top. I got 8 plus 1 plus 3 is going to give me the absolute value of 12 over the square root of 17. The nice thing, absolute value of 12, and that just, is still just 12. If I rationalize this, then I would just multiply by the square root of 17 and say 12 square root of 17. Oops. Let's put a square root again in there. My bad. over 17. And that would be the distance between that line, y equals negative 4x plus 1. So if you look at this graphically, so I got a graph like this, and then negative 2, negative 3. That would be that particular distance between those. There's the point. There's my line. That's going to be my distance between that point and that line. Okay, and that's just a formula. Got to memorize it, know how to use it, and kind of go from there. Okay. All right, so we get similar situation, but now instead of being in slope-intercept form, now if it's in general form, right, same exact situation, same exact scenario, all it is, I got a new formula because obviously I got A's, B's, and C's versus M's and B's. So my distance is equal to the absolute value again, AX1 plus BY1 plus C all over the square root of A squared plus B squared. So some of you say, well, why would I use how do I know which formula to use, right? It's real simple. Which is your equation given to you? If it's given to you like this, y equals mx plus b, then we use that. If you look at this new equation, which is the exact same problem as example 1, just all it is that equation is now in general form, where you have ax plus by plus a constant equals 0. This is still your x1. This is still your y1, right? So all we're going to do is use the new formula. If we do it right, should get the same exact answer, right? Because the exact same situation, just different looking equation. So D equals the absolute value. Well, now in my new equation, A is positive 4. X1 is still negative 2. Plus my B is a positive 1. My Y1 is still negative 3. And my C in this case now is negative 1 over the square root of A squared. So we're going to say 4 squared plus B squared. So 1 squared. So in looking at this, if I clean up the top, now I get the absolute value of negative 12. That's what that absolute value is there. Over the square root of 17. Oh, the absolute value is going to make it positive. I rationalize. Look at that. Same exact answer. Run out of room. I'll just squeeze it right in there. Okay. So all you see is it's just a different formula, but it does the exact same thing. Okay. Because all we're looking at is if your distance formula, I'm sorry, if your equation is written y equals mx plus b, you're going to use the top one. If it's written as general form ax plus by plus c equals 0, then you're going to use that formula down there. Okay, so just memorize those formulas or have them available while you're doing your homework, and you should be all good to go. Okay, so you got some old formulas, some new formulas. Let's get some practice problems going on here. All right, let's get up here to number 1. Scroll up to the top. Okay, find the equation of a line. Now they're telling us our final answer must be in slope-intercept form, given the point 2, negative 4, that is parallel to 3x minus y equals 1. Well, there's that keyword parallel. If you remember parallel, that just means we're looking for a line that has the same slope of what's given. So if I take that 3x minus y equals 1, if I want to find the slope of that line, you typically remember from algebra class, we would just solve for y, right? So if I just solve for y, I'm going to get 3x minus 1. Do your work, do your algebra carefully, please get it correct. So I get y equals 3x minus 1, but I want the same slope. So all I need to get from this information is the slope, right? Y equals mx plus b, so that means my slope is 3. So I'm going to do is keep the exact same slope, y equals 3, or sorry, slope is 3, okay? Now, I have to go through and find the equation. The bad choice is for someone to go through and just say, oh, negative 4, because that's up here, that must be my y-intercept. And I've seen this way too many times. Students just go, oh, y equals 3x minus 4. No, 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 no. Do not do that. Do not be that person with big X's and lines through your answer. Please don't be that person. Instead, if I want to find the equation of a line, if I'm given a point, and I have my slope, well, I can use the formula I told you on the front side and use my point slope. And real simply, it's just y minus y1 equals m parentheses x minus x1. And I'm just going to plug information in. Y minus y1. Well, that's why they gave us this point. This is our x1. This is our y one. So I'm going to go y minus a negative 4, make that a plus 4, equals the slope of 3, right? That's what we just got from over here. And then I'm going to say x minus 2. And this is a perfectly good answer in most instances. A lot of times calculus, they'll tell you just to leave your answer like that. So if you leave your answer like that, awesome. The problem is they specifically said slope-intercept form. So you got to go through the process of solving for y. So distributing the 3, subtracting the 4. If you do it correctly, pause if you need to. Otherwise, get and then check your answer. I got 3x minus 10. And that would be the equation. See how I didn't get the minus 4? Hopefully you didn't do that. Hopefully you weren't silly. You went through and actually did the point slope formula and you got the correct answer and got a perfect score. Awesome. Sounds good. Okay. All right. There's number 1. Number 2. Find the x and y intercepts of a circle with a center at 1, 0 and a radius of 5. So this is where you may have to go back and get that equation for the circle where you say x minus h squared plus y minus k squared equals r squared, right? That was from the front page or hopefully from memory. So what I'm going to do is just plug in. It says the center is 1, 0. So I'm going to rewrite this as x minus 1 squared plus, I can write y minus 0 squared if you want, or you can just say y squared. And I got a radius of 5, so I know that this is going to be 25. Okay, so all I'm doing is find the x, y intercepts with that information. So in looking at that, now you can kind of say, okay, well, if you want to think about this graphically, my center here is at 1, 0, and I'm going to go up 5 for radius, down 5, left 5, right 5, right? So hope you drew a better circle than that. But so I'm looking for the x-intercepts first. I'm looking for those guys first. All right. So if I want to find the x-intercepts, remember from algebra class, really simply, the x-intercepts is just when the y is equal to 0, right? Over here, y equals 0. Over here, y equals 0. So if I take this equation and I plug in 0 for y, I'm just going to have x minus 1 squared is equal to 25. Now I got to go through and just do some algebra. So if I take the square root, I have x minus 1. Now here's where students forget. Look, we're going to get 2 answers. Some students are just going to put 5 because they said, oh, the square root of 25 is 5. But when you're solving an equation, remember, in order to get 2 answers, you need plus or minus. Of course, you remembered that. I was just thinking about those other silly students that may have forgotten. So now to finish solving for x, if I add 1 to both sides, I get x equals 1 plus or minus 5, but that looks kind of weird that way. So I'm going to clean it up and say 1 plus 5, that's 6 comma 0, and then 1 minus 5, that's negative 4 comma 0. I'm going to write it as a great answer as ordered pair because that's what x and y intercepts are, as ordered pairs, not just numbers. Please do not just write numbers as answers. You will probably lose points. All right. So it looks kind of like, yeah, it looks kind of 6 comma 0, negative 4 comma 0. I think that's pretty good. All right. Next thing we got to look for then is the y-intercept. You know what we'll do? We'll make a little different color here. Try and separate the two, right? All right, so we got the y-intercept. If you remember the y-intercept, well, that occurs here and here. Well, that occurs when x equals 0. So if I take x equals 0 into that original equation that we just talked about over there, I'm going to have negative, 0 minus 1 squared plus y squared equals 25. Hopefully remember negative 1 squared, that's positive 1, right? 1 plus y squared equals 25. Subtract it over the 1, do correct order of operations. Now I might take the square root. So I'm going to go ahead and get that y is equal to, again, we got 2 answers because you have a plus or minus. You got the square root of 24. Hopefully remember how to simplify radicals, and we can say that's 4 and 6 or 2 radical 6. That is not a good answer the way I have it written like that because I need to make sure I write it in correct ordered pairs. And I'm going to say 0, 2 radical 6 and 0, negative 2 radical 6. And you can see that one's right there. You see one's right there. And there would be my y-intercepts. Okay. So again, just remembering the circle equation, right? Plugging your info in and then getting some algebra for x-intercepts and y-intercepts when y equals 0, x equals 0. Some good review right there for you. Okay. All right. Let's take a look at number 3. A little bit trickier here. Find the distance between 2 lines given those two equations. So if we think about it, well, what have we talked about? We've talked about how to find the distance between a line and a point, right? We talked about on the second page. So what I look here, if I say, well, I don't have a line and a point, I have two lines. Well, what I can do is I can find the one of a point on one of the lines, and then I'll have a line and a point. So real simply, right? If I were to go through and let's take this guy, and you could do it either way. You can solve for y. You can put in general form. I think it might be easier to do general form and just say negative 2x plus 3y minus 12 equals 0. What I can do is I can manipulate this equation. If I want to find the y-intercept, right? It's a line. It has to have a y-intercept unless it's vertical. So if we just practice this, if I make x equal to 0, well, I'm going to get that I have 3y equals 36. So y is 12. So I know 0, 12 is that y-intercept. So now I have a point and I have a line. So you go back to the front page. If you haven't memorized yet, if you have, awesome. If you haven't, we'll write it over here, right? D equals the absolute value of ax plus by plus c. Oops. I want to have absolute value, my fault, over the square root of a squared plus b squared. So now I'm just plugging my stuff in, right? Here's my a, there's my b, there's my c. Here is my x and my y. Just going to put stuff into the equation just like we did on the front side, or the page 2. So d equals the absolute value. A we know is negative 2. X, when we found the y-intercept, we got 0. And then we know that b is a positive 3. Y in this case is a 12. And then c is negative 12, the absolute value of that, over the square root of negative 2 squared plus 3 squared, right? Just plugging information into my equation. The numerator, well, the nice thing is that goes away. So I have 36 minus 12 is going to give me 24. Absolute value still keeps 24. In the denominator, I have the square root of 13. And if this was a show you work, you want to leave your answer like this, that's perfectly correct. Probably what you've been trained to do is to rationalize your answers, and multiple choice is going to be rationalized. So let's practice multiplying. And there we go. So that would be the distance if I drew, and if hopefully you recognize these two lines would be parallel to each other based on if you solve for y and tried to graph the two lines. And since they're parallel to each other, what will happen is that you would end up getting the distance between them, no matter where you're at, because they're parallel. The distance between them is always going to be 24 radical 13 over 13. Okay? All right. One last one. Probably a little bit of a doozy here. Let's see how we do. Number 4, find the slope of the line tangent to the circle. The line goes through 0, negative 5, and the circle is given with that equation. Hopefully say, well, what do I get from this equation? That's what I would do first. We got a circle here, so the center is at 3, 0, and I have that the radius is 2. And being I'm a visual person, if I were to draw out this kind of scenario that's going on right here, I would say, okay, we got 3, 0 right there. We got a radius of 2. So I know my circle, hopefully drew a better picture than I did. Circle kind of looks like that, right? Okay. Now it says the line goes through 0, negative 5, so somewhere down here. And what we want to do, just get an idea of what's going on, is our job is to find the slope of this line. Because it's tangent. Remember tangent from geometry class or last year, tangent means that it just touches the circle at one particular point. Okay, so that line just touches that circle at that one particular point. So our job is we want to find the slope of that line. All right, so you're saying, well, how do we do this? Well, let's take a look. So if we just used a formula that helps us find the distance between a point and a line. So what I can do is I can say, well, I know the distance from the center of a circle to anywhere in the circle is the radius. So I know that the distance between this point and that blue line is 2, because that's what the radius is. So I know that the distance between them is 2. I also know that the equation of this line, well, since it goes through 0, -5, right? I know the equation is y equals, I don't know the slope yet, but I do know the y-intercept is -5. So what I have now is I have a point, right? 3, 0. I have a line, y equals mx minus 5, and I know the distance between that point and that line is 2. So what I can do is I can go through and I can use my distance formula from the front side. And since I had the equation in y-intercept or slope intercept, I would just use the distance formula d equals the absolute value of mx plus by, plus b minus y, oops, a little mistake there, apologize, over the square root of 1 plus m squared. Try that again. That's better. And so what I'm going to do is just plug in information. Now, the difference with this and the previous side is we know what the distance is. So I can put that number in right away. What I do not know is what the slope is. So I'm going to leave that as m. I know that the x-coordinate is 3 because I got that from the circle. So that's 3. Plus my y-intercept we know is -5 because that's from the information there of that line, and then minus the y value is 0. Again, that's from the center of that circle, all over the square root of 1 plus, we don't know what the slope is. So all I'm going to do is take this equation and clean it up, right, and solve for m here. So make sure you realize this is an absolute value. Okay, so what I would do is, if I make this over 1 and I cross multiply, I'm going to give myself a little more room over here. I have 2 times the square root of 1 plus m squared is equal to, well, the nice thing, I'm going to have the absolute value. If I clean it up, I have 3m minus 5. So now I say, well, how do we solve this? Well, the nice thing you can do here is you can take the square of both entire sides. And in doing so, we are going to get, the 2 get squared also, right? So we have 4 times the quantity. Well, the nice thing is the square root and squared get rid of each other. So I'm going to say just 4 times the quantity of 1 plus m squared equals, well, when you have the absolute value in the squared, it's almost like you don't need the absolute value anymore because the squaring is going to keep everything inside positive. And so I just square this like a normal binomial and just say 3m minus 5 quantity squared. And in doing so, I have 9m squared minus 30m plus 25. So all I did was I treated that, the squared quantity with the absolute value kind of get rid of each other, and I can just set this up and I can go through and multiply it out like we've done before this year. If I distribute my 4, right, so I have 4 plus 4m squared equals 9m squared minus 30m plus 25. I'm getting low on room here, so if I make this equal to 0 because I got a quadratic, like I said, getting a little low on room here, so I'm just going to go up there, and I'm going to say, well, if I subtract, please do it carefully. I have 5m squared minus 30m, and if I subtract the 4, I have plus 21. That equals 0. So now you could go through and solve this quadratic any way that you want. You could do quadratic formula, which I'd highly recommend. If it's a non-calculator problem, you have to know how to do that. Some of you guys may have some other methods to do. Either way, again, double check my answer. Don't just agree with me. Double check that you're doing it right. I ended up with 15 plus or minus 2 square root of 30 all over 5. And that's what I ended up with. Okay? So hopefully you got the exact same answer for that slope. And what that means is, now you say, well, how do you know there's 2? Did you notice that you possibly could have also gone this way? Right? So both of these lines are technically tangent. It's just that one slope is the yellow one is steeper and the blue one is not as steep. Okay, and that's why both those answers are positive, but you do have 2 answers because you could be the yellow line or the blue line. Okay, so there you go. You got some formulas, some good review formulas, and some new formulas. Make sure you're studying and practicing, and ask your teacher if you got questions. All right, good luck.